Imagine knowing exactly which startup is going to be acquired next, way before anyone else even has a clue. Well, welcome to The Explainer. Today, we're diving into a really fascinating intersection of high finance and cutting-edge data science. If you've ever wondered how top-tier investment banks, private equity firms, or corporate strategy teams seem to just magically know which tech startups are ripe for acquisition, you're in the right place. We are going to unpack the exact mechanics of how these massive financial powerhouses are ditching manual guesswork and actually predicting tech acquisitions using machine learning.
So, how do you find the perfect acquisition target before your competitors beat you to the punch? It's literally a multi-million and sometimes multi-billion-dollar question. In the M&A world, target identification is incredibly time-sensitive. I mean, if you spot the perfect venture-backed tech company, but your competitor has already approached them, you've lost. It is a crazy, high-stakes race, and the traditional methods for running this race are just fundamentally breaking down under the sheer volume of data in today's tech ecosystem.
Okay, here's our roadmap for today. We're going to start with the M&A bottleneck problem, introduce the machine learning solution, define success with a metric called recall, map out the cloud architecture behind it all, talk about mitigating implementation risks, and finally, look at how this actually augments human analysts. Let's get right into it.
Starting off with Section 1, the M&A bottleneck problem. Specifically, we really need to look at the absolute limits of manual analysis.
There is a stark, undeniable contrast between the old way of doing things and the new. Right now, a lot of firms are still relying on basic Python scripts, somewhat arbitrary heuristic scoring, and these massive, clunky Excel models that, let's be honest, are prone to crashing exactly when you need them most. It's slow, it struggles to adapt when the market shifts, and frankly, it relies way too much on inconsistent human judgment. But the machine learning opportunity? That changes the game completely. It's scalable, it seamlessly processes huge volumes of data, and crucially, it actually learns historical acquisition patterns, meaning it spots these hidden, non-obvious relationships between variables that a human staring blankly at a spreadsheet would just never catch.
Because here is the simple reality. Human analysts just cannot efficiently monitor thousands of private companies. It's impossible. There are way too many venture-backed startups out there. Trying to mentally track data from PitchBook, Crunchbase, internal deal pipelines, news sentiment, hiring velocity, it is completely beyond human capacity. And relying entirely on manual monitoring means you're going to miss acquisition opportunities, period. And missing those opportunities directly hits your bottom line.
Which brings us to Section 2, the machine learning solution, where we'll introduce the specific engine that actually solves this bottleneck.
To solve this problem, data science teams frame it as a supervised classification model. Basically, this means the system is specifically engineered to predict one singular, incredibly high-value probability. Will a specific venture-backed U.S. technology company be acquired within the next 24 months? And to make sure that two-year prediction horizon is remarkably accurate, we use a standard 80-20 data split, training the model on 80% of the historical data and strictly testing it on the remaining 20%.
We feed all this data into an algorithm called random forest. Now, why random forest? Well, because real-world acquisition outcomes are driven by so many interacting, totally nonlinear factors. We feed it company financials, like revenue growth and funding rounds. We give it market signals, like valuation multiples and interest rates. We track company momentum by looking at employee growth and website traffic. We even throw in qualitative signals, like news sentiment or a founder's reputation. Random forest is honestly the perfect architecture here because it handles all these incredibly diverse, mixed data types simultaneously without breaking a sweat.
Let's move to Section 3 and see how this builds into our evaluation strategy. Defining success with recall, and why catching every single opportunity matters the most.
You know, in machine learning, you can optimize a model to do a bunch of different things. But in this specific business use case, our primary metric is something called recall. Recall prioritizes identifying all actual positive cases. Basically, it wants to find every single company that will actually be acquired. It intentionally minimizes false negatives, which are those companies the model predicted wouldn't be acquired, but actually were.
So, why are we so obsessed with recall? Because missing likely acquisition targets is so much more commercially damaging than investigating a dud. Think about the cost of a miss here. A false negative is literally a disaster. It means missing out on a potential advisory deal that could have brought in millions in fees. But a false positive? That just means the model flagged a company, an analyst spends 10 minutes reviewing it and decides, nah, it's not a fit. The system prioritizes recall because humans can always quickly filter out false positives, but a missed opportunity, that's gone forever.
All right, moving to Section 4.
designing the cloud architecture. Let's lift the hood and see how this ML system actually operates in a real-world enterprise environment. Look, building a cool model on your laptop is one thing. Deploying it across a global investment bank is a totally different ballgame. You have to make some very practical, enterprise-ready architectural choices. First, we go with a cloud environment because we absolutely need that scalability and access to massive, centralized financial datasets. Second, we use offline learning instead of real-time learning because financial market data mostly updates periodically anyway, and it makes governance and monitoring so much easier. Finally, we use batch predictions. We don't really need sub-second real-time predictions. We need thousands of companies scored simultaneously so the data is completely ready to go when the advisory teams log in.
And those choices set up a really beautiful operational rhythm. Because of this batch offline architecture, the model can actually retrain nightly to pull in the latest market activity. While the analyst sleeps, the machine is crunching the day's M&A sector data, adjusting probability scores, and teeing up a perfectly prioritized list for the next morning. It is just wildly efficient.
But of course, no system is totally foolproof, which brings us to Section 5, Mitigating Implementation Risks. We have got to talk about taming market drifts.
Let's face it, markets are messy and they pivot fast. This creates what we call concept drift. Think about it. In 2020, during COVID, we saw this massive SaaS boom. But by 2022, rising interest rates completely upended how companies were valued. And by 2024, the market shifted aggressively toward AI-focused startups. If your model was trained only on 2020 data, it would completely misread the 2024 market. We also have to watch out for data drift, where the structure or availability of the financial data itself changes over time. Any real-world ML application has to rigorously account for these shifts.
So, to protect the model from just decaying into irrelevance, we implement some very strict mitigation strategies. We use that scheduled nightly retraining to capture new trends. We continuously monitor model performance and periodically review the features to make sure we aren't, say, overweighting highly funded companies based on outdated market vibes. But most importantly, we mandate a human-in-the-loop review. Analysts regularly review historical predictions, top-ranked targets, and crucially, those false positives and false negatives to keep the machine firmly grounded in reality.
And that vital human element leads us perfectly into our final piece, Section 6, Augmenting the Human Analyst. This is all about supercharging human advisory.
There is a really common misconception out there that AI and ML are built to replace analysts. But the truth is, this system supports analyst decision-making. It absolutely does not replace human judgment. The model handles the impossible math, tracking 10,000 private companies across 50 variables simultaneously. But the human handles the nuance. The human builds the actual relationship with the founder, navigates complex board dynamics, and negotiates the final deal.
Ultimately, the whole goal here is to augment their ability to identify high-potential acquisition opportunities at massive scale. By taking that manual, tedious research workload off their plate, we free analysts up to do what humans actually do best, strategic thinking and deal-making. They adapt faster to changing markets because the machine is serving them the exact intelligence they need exactly when they need it. Which leaves us with a pretty heavy final thought. The technology we've unpacked today, it's not some futuristic sci-fi concept, it is being deployed right now. So ask yourself, if your competitor's machine learning model is retraining tonight, processing thousands of data points while they sleep, and handing them a prioritized list of acquisition targets by morning, can you really afford to rely on yesterday's Excel heuristics? It's definitely something every firm out there needs to seriously consider. Thanks so much for joining me on this explainer, and keep learning.